variant that we are going to see is the maximization problem. So we'll start with a numerical, a very interesting numerical that we have. A company has 4 territories. Company has 4 territories. Open and it has 4 salesmen and 4 salesmen available for assignment. The territories are not equally rich. In their sales potential. It is estimated that a typical salesman operating in each of this territory, salesman operating in each territory would bring in the following annual sales. So we have a territory and the average annual sale that will be produced by any average salesman has been given to us. So there are 4 territories. So first territory is around 60,000. Next is around 50,000. Third is around 40,000. And fourth is then 30,000 annual sales. Right. So it is a 0 here. I guess it is 30,000 annual sales. The 4 salesmen are also considered to differ in ability. Right? To differ in ability. It is estimated that working under the same conditions, their yearly sales would be proportionately as follows. So salesman and the proportion has also been given. A, B, C, 7, 5, 5 and 4. Now they have said that if criteria is max estimated total sales, right? If the criteria is maximum expected total sales, do the assignment. Such simple thing that they have given. So we have the criteria as the maximum estimated total sales. Now let's understand this numerical, and then we'll be talking about this numerical in while solving. So they have said that the company has the 4 territories which are open, and the 4 salesmen available for the assignment. The territories are not equally rich in their sales. So every territory, what will happen is that the sales that this territory generates are different, hence their sell potential is also different. So it is estimated that a typical salesman operating in each of this territory would bring the following annual sales. So any salesman who can who is averagely operating can produce the following sales. So territory 1 will produce 60,000 sell, 2 will produce 50,000 cell, 3 will produce 40,000 cell, and 4 will produce 30,000 cell. They are saying that the 4 salesmen are also considered to differ in their ability. So that is very obvious. None of these salesmen, they will be definitely having the different abilities. So it is estimated that the working under the same condition, their yearly sales would be proportionately as follows. So if they are working in the same conditions, the proportion of the yearly sales that they would generate is given in the following manner. So for example, salesman A will generate 7 proportion of the total, 7, the proportion of his cell would be 7 in with respect to all these cells, right? So the proportion is 7, for B it is 5, for C it is 5, and D it is 4. Now if the criteria is maximum estimated total cells, they are telling us that to do the assignment. So now what we have to do is, now they haven't given any cost matrix, they haven't given anything other than this, right? So now what we are going to do is, we in ourselves we are going to generate particularly the cells that these salesmen can generate. So now we'll have to, particularly we have to increase the cells, the maximum estimated total cells. We'll have to focus upon maximization of the total cell, but because before that we'll have to have the cell matrix, right? So if we are having cells matrix, what would be easy? The maximization of the cells matrix would be easy, right? So if we have the cells matrix, the next procedure is very same as that we did in the in our transportation problem. So the same will be also the same will be also repeated here. But this particular numerical is different in its type, because we do not have the cells matrix as of now. So what we are going to do is, now we are going to generate a cells matrix, and then we are going to attain this problem, right? So let's focus upon this particular thing first, that is the generation of the cells matrix. I'm hoping that you have understood the numerical, and let's proceed ahead to solve this numerical, right? So we have that the we have been previously given, so salesman and its proportion was given to us, right? So salesman and its proportion was given to us. So for example, mm, D it is 4. So this particular proportion is given to us. Now the sum of the no, all this proportion, that is the sum of cells, that no, sum of cells of these salesmen we can consider as 7 plus 5 plus 5 plus 4 is equal to 21. So if we have the 21 number of cells, out of that 7 are of A, 5 are of B, 5 are of C, and 4 are of D. So that makes sense, right? So the sum of the cells of this salesman is given here, right? Now let's understand. Let's take the cells of rupees 10,000 as 1 unit of the cell, and the annual sales of the 4 salesmen in the 4 territories can be calculated. For example, let's what I've told now is, let's consider uh, 10,000 as 1 unit, right? So 10,000 rupees, 10,000 as 1 unit of cell, and then the annual sales of each salesman in each territory can be calculated. Each territory can be calculated. How can be calculated? We know that, right? So the total cell is there. So 7 by 21 proportion is done. Out of that, 7 by 21 proportion is done by A. 5 by 21 proportion is done by B. Say 5 by 21 is done by C, and 4 by 21 is done by D. So if I'm having territory 1, so for territory 1, or particularly why to go territory wise? Let's go salesman wise. Salesman wise. So it will be easy for preparation of matrix. So for salesman A. So for salesman A, so how much is the annual sales in territory one? It was 60,000. So the unit is 60. So the unit is 6 because 10,000 is equal to 1 unit, right? So for territory, should I write it again here? For territory, and here it is annual sales. So for territory 1, it was 60,000. So that happens to be 6 because 10,000 is equal to 1 unit. For second, it was 50,000. So it will be turning out to be 5. For third, it is 40,000. Turns out to be 4. And for it was 30,000. So it will be turning out to be 3, right? So for salesman A, what we can write it down is for the territory 1, it will be how much? It will be 7 by 21 into 6. For territory B, it will be 7 by 21 into 5. For territory 3, it will be 7 by 21 into 4. And for territory 4, it will be 7 by 21 into 3. Right? So what is 7 by 21? 7 by 21 is because it is having 7 proportion in 21 cells. Similarly, if I have to deal with for B, what we can write it? We can write it as 5 by 21 into 6. For territory 1, it will be 5 by 21 into 5. For territory 2, it will be 5 by 21 into 4. For territory 3, and it will be 5 by 21 into the 3 for territory number 4. Right? So similarly, if we proceed, for C, it will be what we can write for C. It is again 5 by 21 only. So 5 by 21 into 6, 5 by 21 into 5, 5 by 21 into 4, and 5 by 21 into 3. For D again, it will be what we can write. Now it is 4 proportion of 21. So 4 by 21 into 6, 4 by 21 into 5, 4 by 21 into 4, and 4 by 21 into 3. Right? So now particularly all this will be the values of the matrix. Right? So if you have to know, if I have to make a matrix, so 7 by 21 into 6, so that matrix, so that value will be put in that particular cell. So for example, if I have to make this matrix here, right? So here it will be like this, right? So it will be A, B, C, D on the this side, A, B, C, and D on this side, and it will be 1, 2, 3, and 4 territories here. It is 1, 2, 3, and it is 4 here. Right, so 1, 2, 3, and 4 here. So what will be the value here? The value here will be 5 by 21. Sorry, it will be 7 by 21 into 6 here. Here it will be how much? Here it will be 7 by 21 into 5, 7 by 21 into 4, and here it will be 7 by 21 into 3. Similarly, here for B, it will be 5 by 21 into 6, 5 by 21 into 5, 5 by 21 into 4, 5 by 21 into 3. Here again it will be 5 by 21 into 6, 5 by 21 into 5, 5 by 21 into 5, and 5 by 5 by 21 into 4, and 5 by 21 into 3. Here it will be 4 by 21 into 6, 4 by 21 into 5, 4 by 21 into 4, and 4 by 21 into 3. Right? Now if you try to solve this value, for example, 7 by 21 into 3, 7 by 21 into 6. So 7 by 21 into 6 will be giving you a fractional value. So all these values of like 7 by 21 into 6, 7 by 21 into 5 or 5 by 21 into 4, all will give you what? Will be giving you an yearly cell. That is okay, but you'll be getting a fractional value, and fractional values are very, very difficult to handle, right? So if you are going to do the assignment problem, so again it will be a difficulty for us to do in such case. So for example, now what we are going to do is we are going to make it easy for us. So for a year, right, so it was regarding a year. For year, so for A we have 7 by 21. So for territory 1 we have 7 by 21 into 6. So to avoid getting fractional value, we are not going to consider it for a year. So we are going to consider it for 21 years. So if we consider it for 21 years, so what will happen for A? It will be 7 by 21 into 6 into 21. So this 21 will get cancelled. You will be given 7 into 6 into 42. So if we so here the value will be 42. So 42 is easy to handle, right? But again, the fractional values will be very difficult. So similar way, we can complete this table by considering the 21 years. So you can write here. So avoid the fraction values, or even you can do with the fraction values. I don't have but you'll be getting the same answer at the last. So avoid the fraction values by considering 21 years for the cells calculation. So if we do so, we'll be avoiding to get the fractional values, and you'll be getting the whole numbers, and that are very easy to handle. So if you do so, you will be you practice at home. And so how this 35 will come? 35 will come as 7 by 21 into 5 into 21. So 7 5 the 35. Similarly, the value will come here at 28. It will come here at 21. So it is 30, 25, 20. 15, here it will be 30, here it will be 25, it will be 20, here it will be 50, here it will be 24, here it will be 20, here it will be 16, and here it will be 12. Right? Now particularly you have to remember at the last that you have considered it for 21 years. So now that particular 21 years should be taken into significance. Now let's focus upon what has been asked. This now particularly the given problem is a maximization problem, right? So we have to maximize this cells, right? So we have to maximize the above matrix. The given problem is a maximization problem, right? But assignment model deals with minimization problem. So that is the case. So convert, what will I have to do? Convert maximization problem into minimization problem. So how will we doing so? We have already seen 3 approaches while dealing with the transportation problem, but we had a very easy approach. So what we are going to do, we are going to select the maximum number from above matrix, and then all the other cell values we are going to subtract from that maximum number. So the maximum number from above matrix is 42. Yeah, it is 42. Subtract all the cell values from 42 to convert the maximization problem into minimization problem. So I'm hoping that you remember this. This is the same approach that we are seen in the transportation problem, but we are going to repeat here. right? So the matrix I'll be repeating again on the next page, and then we'll be for converting the maximization problem into a minimization problem, right? So what we have here is, just a second. So no, we'll be converting the maximization problem into a minimization problem. All right. So the matrix that we have for the maximization problem is like this: is A, B, C, and D. One, two, three, and 4. All right. So the matrix was 42, 35, 28, 21, 30, 25, 20, and 15. 30, 25, 20, and 15. It is 24, 20, 16, and 12. So this was the no matrix that will have maximization matrix. So we'll have to convert it into the minimization problem, right? So what we are going to do, we have the maximum number as, what is the maximum number? It is 42. So it is to be subtracted for everything. So 42 minus 42 is 0. 42 minus 35 is 7. 42 minus 28 is 14. 42 minus 21 is 21, right? So 42 minus 13 is 30 is 12. 42 minus 25 is 17. 32 minus 20, sorry, 42 minus 20 is 22, and here it will be 42 minus 15 is 27. The same will be repeated here again. It will be 12, 17, 22, and 27. And lastly, 42 minus 24 is 18. 42 minus 20 is 22. 42 minus 42 minus 16 is anyone? 42 minus 16. It is 26, and here we have 42 minus 12. Here we have it as 30, right? So I'm hoping that all the values are correct. So let's move ahead and do this matrix calculation properly. So now what we'll have to do is, now we'll have to go for the row reduction, right? So the row reduction, if we do, so row reduction, firstly, the minimum value is 0 only here. So the entire row values will remain constant in first row. Just a second. We have it as A, B, C, D, 1, 2, 3, and 4 here, right? So 0, 7, 14, and 21. So we have this. Nextly, in row number B, the minimum value is 12, right? So 12 minus 12 is 0, 17 minus 12 is 5, 22 minus 12 is 10, and 27 minus 12 is 15. Nextly, the same values will get repeated again, right? And lastly, we have 18 as a smaller value. So 18, right? So 18 minus 18 is 0. Yeah. 22 minus 18 is 4. 26 minus 18 is 8. And it will be 30 minus 18. 30 minus 18 will be 12. Right? So I'm hoping that you have understood this. Let's do, is there any need of column reduction? Yeah, there is need of column reduction, because we do not have the 0 in each and every cell. So we'll have to do the column reduction. So while doing the column reduction, what will happen is that Here we have A, B, C, D. Here it is 1, 2, 3, and 4 here. So no, here the values will remain same. Here the minimum value is 4. So here it will be 3, 1, 1, 0, right? Nextly we have 14, 10, 10, 8. So the minimum value is 8, right? So 8 minus 14 minus 8 will be 6. Here it will be 2, 2, and here it will be 0. Nextly we have 21, 15, 15, 12. So minimum value is 12. So 12 plus 8 is 20. It will be 9. It will be 3 here, 3 here, and 12 minus 12 is 0. So the column reduction and row reduction has happened. So doing the row scanning, row and column scanning, what you will be getting is this particular thing. So here we have only 1 0 in row number A. So we can make a square to this 0, and we can draw a vertical line. In column number, in row number B, it is not possible. Row number C, it is not possible, and row number D, again, it is not possible, right? But now let's move for the column scanning. In column scanning, row number 2, we can do the column scanning. So we have only 1 0, and we are going to put a horizontal line. So now we can see all the zeros are cut, and the minimum, the number of squares that we have are how many? The number of squares are 1 and 2, and number of columns or the rows that we have are 4. Hence iterate further. Minimum value that we have is 1. Minimum value 1. Reconstruct and scan, right? So if we are going to do the reconstruction, right? So 1, 2, 3. Here we have 4, right? So A, B, C, D. It is 1, 2, 3, and it is 4 here. So 1 is the lowest value. So the intersection is happening only at this particular cell. So 0 plus 1 is 1. So other these values which are deleted remains constant. So here 3 minus 1 is 2, 6 minus 1 is 5, 9 minus 1 is 8, 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2, 1 minus 1 is 0, 2 minus 1 is 1, and 3 minus 1 is 2. So we can do scanning here. For the scanning purpose, yeah, there is 1 0 here. So we can put a square here, and then we can draw a vertical line. Now in row number 2, again there is 1 0. So we can do a square here, and we can put a 0. Row number 3, we do not have any choice, right? And row number 4, again there are 2 zeros. We do not have choice. Do the column scanning. Row number 1, column 1 and 2 has already been exhausted, or no, already been cancelled. Row number in column number 3, we have exactly 1 0, and we are going to draw a horizontal line. So now here you can see the number of squares that we have is equal to 3, and number of rows and columns that we have is equal to 4. So hence we'll have to iterate further. All right. So I'm going to draw this on the next page, just for the sake of particular, we don't need any confusion. So let me repeat it here. So the same matrix. Right, so it is 0 2 5 8 2 5 8. It is 0 0 1 2 0 0 1 2. It is 0 0 1 2 0 0 1 2. It is 1 0 0. We've already done the row and column scanning, but for the sake we'll be doing it quickly here again. Right, so this was the case. So here minimum value identified as 1. So minimum value is, so reconstruct and scan. So after reconstruction, so it is A, B, C, D, 1, 2, 3, and 4 here. So there is intersection that is happening only at this junction. So 2 here, all the deleted cells will remain constant. So here it is 4. Here it will be 7. It will be 0, 1, 0, and 1. Right. So let's do the row scanning and the column scanning again. Right. Are we going correctly? Because I don't have the solution. So I guess that no, we are going in correct manner. So here 0 here, and we are going to cancel this. In row number 2 we cannot proceed, row number 3 we cannot proceed, and row number 4 again we cannot proceed. In column number 2 we cannot proceed, column number 3 we cannot proceed, and column number 4 we can proceed here. So column number 4 I have one single 0, and no, I'll be drawing a horizontal line. Right, in column number 2 again we cannot proceed properly as a row scanning. Row Even in row number C we cannot proceed for row scanning. Column number 2 we cannot go for column scanning, and column number 4 we cannot go for the column scanning. So here what we'll have to do is we'll have to think of arbitrary assignment, because unless and until we do that we cannot move ahead. So here let's do an arbitrary assignment here, and doing an arbitrary assignment here, and I'm cancelling this, and then I have an only option of this, and this is the case with me. So now the number of squares is equal to how many? Number of squares is equal to 4. Number of columns and rows that we have are equal to how many? Those are also equal to 4. Now let's particularly think of that. Hence we have got, hence optimal solution is reached. Now how to move ahead, right? So we have achieved the optimal solution here now, right? So the maximum annual cells that we have to estimate. So maximum annual cells will be what? So according to this particular last assignment and our first cost matrix, so the the values that we can find out are, what are the values that we'll have to write. So for first it is first, so that will be 42. Nextly for second it is second, so it will be 25. So here it will be 20, and here it will be 12. Right. So all this, and these were as we all remember, these all were for 21 years. So we'll have to divide it by 21 to get an annual cell, right? So any one of you can do this and tell me what is the value of this, right? Because I don't have the last solution with me. Quickly, can anyone tell me what is the answer of 42? Then we have 25, then we have 20, and then we have 12, and addition of all this comes out to be how many? It comes out to be 99, and 99 divided by 21 is equal to 4.71. So 4.71. Again, what is 4.71? 4.71 is the value that we are getting, but no, we'll have to multiply it with 10,000. So what is the answer that you're getting finally? Probably 47,142.86. So 47,000, or we can say 47,000 only.